Hello everyone, welcome to Almighty Tricks. So today we'll be solving one question from the LeetCode. The question is bulb switcher. So in this question, it will give an n bulbs, and initially the bulbs are off, and we need to count number of bulbs after n steps which are on. So let's understand what this question is asking. So the question is saying we can have n bulbs. Let's say n is 3. And I will be denoting 0 edge off and 1 edge on edge for understanding purpose. So initially the bulbs will be off, so it will be 0 0 0, 3 bulbs it will be off, and we need to find number of bulbs which are on after n steps. So we need to take 3 steps after so each step we need to toggle these bulbs. So in the first step 1, so it will be toggle and it will become 1. This one also toggle 1 1. And step 2, in the step 2 we need to toggle those bulbs which are factor of 2. Okay, so this is 1 place, second place, third place. So this one will be as it is for step 2, because we need to toggle only 2 factors place. So this one is 2, so we need to toggle as 0. This one also we need to put as it is, because 3 is not factor. Okay, then step 3, in step 3 we need to toggle uh, uh, factor of 3. So 1 it will be as it is, this one 2 also it will be as it is, and this one will toggle to 0. So finally the answer will be number of bulbs which are on. So the answer is, for n is equal to 3, the answer is 1, because there are only one bulb is on. Okay, let's take a bigger example. Let's take n is equal to 5. N is equal to 5. So initially the bulb will be off. 0 1 2 3 4 and 5. Let's number it up. 1 2 3 4 5. Okay, so the first step is step 1 is 1. So in the step 1 we need to toggle, so it will become 1 1 1 1 1. Sorry, it will be 1. Okay, now in the step 2, so in the step 2 we need to toggle the bulb which are 2's factors. So 1 will be as it is, 2 will toggle to 0, 3 will be as it is, 4 will toggle to 0, 5 will be as it is. Then step 3, in the step 3 it will become 1 will become 1 as it is, 0 will as it is, and third will toggle, because 3 is the factor of 3, so it will toggle to 0. This one as it is, this one also as it is. And step 4, in the step 4, 1 2 3 everything will be as it is, but 4 will toggle to 1, and 5 will be as it is, because 5 is not factor of 4. Then at step 5, so 1 will be as it is, 2 3 4 also as it is, and 5 will toggle to 0. Now there are 2 bulbs which are on, so the answer is 2. Okay, let's take n is 9. So initially it will be off. 1 2 3 4 5 6 7 8 9. So number it 1 2 3 4 5 6 7 8 and 9. So for step 1, so initially it will toggle 1 1 1 1 1 1. It will toggle. For in step 2, the 2's factors will be toggle, so it will be 1 will be as it is, then 0 1 0 1 0 1 0 1. First third factor, 3's factorial will be 3's factors will be toggle, So 1 0 0 0 1 1 1 0, then ninth place will become toggle. Then for fourth step, 1 0 0, four factorial, 4 factor will toggle 1 1, as it is will be there 1 1, eighth place will become 1, ninth place as it is 5 step, so 5 factors will toggle 1 0 0 1 0, so 5 factors will toggle, then 1 1 1 as it is will be there. Then for sixth will be, so as it is 1 will be there, 6 factors will toggle only, so 0 0 1 0, 6 factor will be 0, then 1 1 0, then 7 factors will toggle 1 0 0 1 0 0 0 1 0, then 8 factors will toggle 1 0 0 1 0 0 0, 8 factor will become 0, then ninth will be as it is. Then for ninth step, 9 factor will be 0 1 0 0 1 0 0 0 0 and 1. Okay, so finally if you see for n is equal to 9, so we have 3 balls are on. Okay, so the answer will be 3. So if you observe one thing here, so for 9 we have the bulbs are on at first position, fourth position and ninth position. Okay, and when for n is equal to 3, the bulbs are on at first position, right? This is first position, so it will be 1. Okay, for n is equal to 5, it is on at what position? It is on at first position, then fourth position, first and fourth position. If you observe one thing here, so we can write like this, right? 1 to the power 1, 1 each, like square, 2 to the power 2, 9 to 3 to the power 2. Okay, similarly this one also 1 power 2, then this one also 1 power 2, 2 power 2. Okay, so if you see, we are getting answer for each perfect square. So 2 into 2 is 4, right? And 3 into 3 is 9, right? These are the perfect square. 1 into 1 is 1, right? These are the perfect square. So what we need to do, we need to take a for loop. And we'll start with I equals to 1 till n, till n position. Okay, and we need to do we need to go till root over square root of n, we need to go, and we need to count. So this count will give the number of balls which are on. Okay, so how we can write that? We can write I is equal to 1. To get the square root of n, we can write like this: I into I, okay, less than equals to n, then I plus plus. Okay, then we increment the count plus plus. So will be the answer. Okay, let's code this one. We can take, so first of all we need to check some base conditions, like if n is equals to 0, then return 0, because no walls will be on, right? If n is equals to 1, so we know that this we need to return 1, because initially the bulb will be off, so at the first step it will be become 1. Okay, now we'll take the for loop for, so we'll take the count variable count equals to 0. Okay, we'll take int I equals to 1, so it will go I into I till n equals to n. So it will be like square root of n. I into I means what? I into I square less than equals to n, it means square root of n. Okay, then I plus plus, and we need to run count. We need to increment the count, then we need to return. Okay, so run this. This is small n. Okay, so hope you understood this approach. Thank you for watching this video.